All right, the directions are simply, for first time in the chapter, are going to say solve. That means there's an equals, and we'll be able to calculate what the variable value is. So again, we're going to start off simple. We have the square root of x equals 7. So remember what our first step said was to get the radical alone on the left and everything else on the right. And they've already taken care of that for us in this problem. So we're already to step 2. So I'm going to rewrite this problem again, which says go ahead and square both sides. Now, squaring both sides, I don't need to write plus or minus. It's when I take the square root of a variable that I need to do plus minus. So the square root of a quantity squared is the quantity, so I just get x, and then I get 7 squared is 49. So now what I'm going to do is a check on this and to see if 49 makes sense. So is the square root of 49 actually equal to 7? And square root of 49 is 7, and 7 equals 7. So what that says is x equals 49 is an acceptable answer. Craig, are you writing down stuff? Okay, let's try another one. All right, we'll get a little bit more complicated. We're just kind of easing ourselves into complication. So the only thing that's under the radical is this 2n, and then outside the radical it says plus 3 equals 1. All right, so is my radical isolated? No. So what do I need to do to get the radical by itself? Yeah, I'm going to just subtract 3 from both sides. So that gives me radical 2n equals negative 2. All right, so now what I'm going to do, I'm going to rewrite the problem. And I'm going to go ahead and square both sides. And radical 2n squared is 2n, and negative 2 squared is 4. Now, if you notice this problem, I'm not done yet. There's still some math that needs to be done. So I'm going to continue doing opposite operations, and I'm going to divide both sides by 2. And I get n equals 2. So now I'm going to go ahead and do my check and see if the square root of 2 times 2 plus 3 equals 1. And that would give me the square root of 4. And the square root of 4 is 2. And 2 plus 3 is 5. And 5, whoa, doesn't equal 1. Because 5 doesn't equal 1, what that tells me is that n can't equal 2. And that's the only value we could come up for n. So what we write is no solution. Now, there would be a solution, but it would be in the imaginary system, but we're not studying the imaginary system. So for us, there is no solution to this problem. And where you might have caught a little glimpse of there being no solution was right here. The only time that you can take the square root of a value and get a negative is if there was a negative outside the square root symbol. And there was nothing outside the square root symbol. So that was a little indication that you were going to get something that wasn't going to work out. All right, let's see. Let's try another one. So we've got the square root of 4a over 3 minus 2 is on the outside equals 6. So we have the same issues we had on the second problem, that the radical isn't isolated. So doing opposite operations, we would add 2 to both sides. And that gives me the square root of 4a over 3 equals 8. I'm going to rewrite that again. Now, do note that that 3 is also under the radical. And now I'm ready to square both sides. So the square root of a quantity squared is the quantity, so we just get 4a over 3, and 8 squared is 64. All right, who can tell me how in one step I'm going to get that a alone? In one step. Craig? We're going to multiply both sides by the reciprocal 3/4. And look for canceling. 4 goes into itself once and into 64 16 times. And we're left with a equals 48. And then we're going to go ahead and do our check. And here's something you guys need to understand. Notice that in the numerator of a 4 times a 48 divided by a 3. I don't have to multiply 4 by 48 and then see if I can divide a 3 out of it. I can leave it in its factored form, and I can look for things that I could cancel out. So for example, 3 can go into 48 16 times. So here's really what that problem looks like on the left. Is I've got the square root of 4 times the square root of 16 minus 2, and we're still trying to see if that equals 6. Well, the square root of 4 is 2, and the square root of 16 is 4. And 2 times 4 is 8. And 8 take away 2 is 6. So what that says is I agree that A has to equal 48. Okay? All right, next. Number 4. We have the square root of 4y minus 3. That outside, okay, back again. So we have square root of 4y minus 3, and then outside of that, plus 6 equals 10. So just like the last couple problems, the radical wasn't isolated, so we're going to do opposite operations to do that. We're going to subtract 6 from both sides. We get the square root of 4y minus 3 equals 4. I'm going to rewrite that. Now that I've isolated the radical, I can go ahead and square both sides. So the square root of a quantity squared is the quantity, so I get 4y minus 3, and 4 squared is 16. Now this one again doesn't have the variable alone, so I'm going to have to continue to solve this equation like we did back in chapter 3, just doing inverse or opposite operations. So we're going to start by adding 3 to both sides. And we get 4y equals 19. And then we're going to divide both sides by 4. And we have y equals 19 fourths. Now at first you might be saying, wow, I don't see how we could possibly get that answer, but that's what the check is all about. So we have 4 times 19 fourths minus 3, the square root of that, plus 6. Does that equal 10? Well, the 4's cancel, leaving me with 19 take away 3, which is 16. Square root of 16 is 4, and 4 plus 6 does give me 10. So since that's true, it is going to be possible that we may get fractional answers on our questions. Okay. All right, a little bit more complicated. We've got 3 times the quantity 2a squared minus 28 equals 6. So back in the beginning I said what we want to try to do is get the radical isolated. That's going to make it the easiest for us to solve. And sometimes we've got coefficients in front of our radical. And that's okay to keep a coefficient there and then square both sides. But then that makes me remember that I have to square that 3 as well. So here's my rule of thumb. If I have a coefficient in front of my radical, I check to see if he can go evenly into the number on the other side. If he can, I'm going to take care of that. Can 3 go evenly into 6? Yes, so let's go ahead and let's take care of it. One less thing for us to have to worry about. So we get radical 2a squared minus 28 equals, come on, Bubba, 2. Now I'm going to skip writing this a second time because you can see it really well when we're using this vehicle. Now that I've isolated the radical, this is the time I get to square both sides. So the square root of a quantity squared is the quantity, so I get 2a squared minus 28 equals 4. So now everything is rational. Now again, I don't want to know what 2a squared minus 28 is. I want to know what a is, so I'm going to start working my way to that place. So we had talked about a chapter 6 version of solving problems with a radical, or with a squared term and no linear term. And we said chapter 6 we get everything on one side 0 on the other, factor both sides, and then set each factor equal to 0 and solve. Chapter 11 says, hey, if there's no linear term, go ahead and isolate the squared term. Now, I don't want to know what a squared is, I want to know what a is. So what am I going to do to figure out what a is? See, Izzy? I'm going to take the square root of both sides, but here's the problem. As soon as I put a square root symbol around the a squared, what has to go on the other side? Plus or minus. There are two possible answers here. I'm not sure which one they want me to have, so I'm going to look for both of them. So I'm going to take the square root of both sides. So I get square root of a squared is a. I just cut the exponent in half because it's a half power. Plus or minus square root of 16 is 4. Now here comes with the check. I'm going to have to check both answers. So let's start with the positive 4. Is 3 times the square root of 2 times 4 squared minus 28, the square root of that, all equal to 6. Well, we get 2 times 16 minus 28 equals 6. 2 times 16 is 32. 32 take away 28 is 4. Square root of 4 is 2. And 3 times 2 is 6. So what that says is it tested positive for positive 4. So this is good. Let's try negative 4. So we have negative 4 squared minus 28 equals 6. So then when we square negative 4, we get 16. And if you notice, at this point, these two are identical. So the outcome should be identical, right? Which means that both answers were good, so we're going to keep both answers. So we could either write the answer that way, or we could say solution set notation plus or minus 4. Okay? So let's go ahead and move on. It doesn't say when, so I'm not sure. Number 6. We have 4 radical x equals 3 radical 2. So again, we have one with a coefficient, and our choice is leave it in front of the square root of x or divide both sides by that coefficient of 4 and get the radical x by itself. The problem with this one is 4 is not going to go evenly into what we have on the other side, so it really doesn't matter. What would you guys prefer? Do you want to see an example where you keep the coefficient there? You want to just keep it like that? Okay, so let me rewrite that problem then. And let's go ahead, and in order to get rid of a square root, we're going to square both sides. Now the funny thing is, we've got square roots on both sides on this particular problem. So what I have to remember to do is square the 4. So that gives me 16. And the square root of x squared is x. On this side, I've got to remember to square the 3 and square the radical 2, which gives me a 2. Okay, so then this gives me 16x equals 18, and then I'm going to divide both sides by 16. I always need to try to reduce fractions. Both of them have a 2 in common, and I get x equals 9/8. So again, a fractional answer. So let's test it to see how it works. Now, I'm going to do the check up next to it because this is a little lengthier check. 4 radical 9/8, so they're both under the radical sign. Does that equal 3 radical 2? So let's see, numerator-wise, I can take the square root of 9 Square root of 8, I'm going to have to simplify. Square root of 8 is 4 times 2, and I'll have to try to take the square root of both of those. So in the numerator, square root of 9 is 3. In the denominator, I have 2 radical 2. We cannot leave a radical in the denominator, so I'm going to multiply top and bottom by radical 2. On the top, I have 12 radical 2 over 2 times 2. Well, 2 goes into 12 6 times, 2 goes into 6 3 times, and I get 3 radical 2 equals 3 radical 2. So what that says is, yep, x equals 9/8. Okay? All right, the last one, of course, is the grand doozy of them all. He's got the most amount of work and the most amount of, well, what ifs. So last one. Square root of 2n squared minus 25, that equals n. So this problem starts off having isolated the radical. What's a little weird is we haven't seen one with a variable on both sides. So let's see how that's going to change up how we end up getting an answer. So we're going to square both sides. And we take squaring the square root, we get the quantity, the radicand 2n squared minus 25. And n squared is n squared. So if we follow what we did in that prior problem, where we get all the quadratic terms, the n squareds together, and then on the left and the constants on the right. So I'm going to subtract n squared from both sides, and I'm going to add 25 to both sides. That gives me n squared equals 25. Well, at this point, I'm ready to take the square root of n squared, but immediately I need to write plus or minus on the other side and then take the square root of 25. And I get the square root of n squared is n plus or minus 5. So again, what I have here is an issue with 2 possible answers, and I need to test both of them. So let's go do the check. Let's start with positive 5. And we want to know if the square root of 2 times 5 squared minus 25 equals 5. So we get 2 times 25 minus 25 under the square root. 2 times 25 is 50 minus 25. Square root of 25. And we always look for the principal square root. The only time I would write a negative is if there was a negative outside the radical sign. So we've tested great for positive 5. Let's try now for negative 5, and let's see how that differs. So we have 2 times negative 5 squared minus 25, and the question is, does that equal negative 5? And what we're going to get here is 2 times 25 minus 25 equals negative 5. And it looks like we've got the same exact thing. And a lot of people would have stopped and said, yep, it works as well. But this is a case where you don't see until you get to the very end. And what we have is positive 5 on the right, or on the left, and negative 5 on the right. So that tells me that it doesn't work for negative 5. So we're going to go back to this answer, and all we're going to get is n equals positive 5. Now, where should you have noticed the problem? You should have noticed it right here. Taking a square root, you can't get a negative unless there's a negative in the front of the square root symbol. So that kind of was the giveaway that you were not going to be able to include negative 5 as part of the answer, okay? Because a square root cannot equal a negative unless there's a negative out in front of the radical. All right, that's it.